Have you ever gazed up at the stars and wondered, just how vast is our universe? Well, let's take a little journey together, y'all. Now try to imagine for a moment that our Earth, this big blue marble that we call home, is the size of a small, humble pea. If that's the case, then our entire universe would be the size of Mount Everest. Yes, you heard that right. Mount Everest, the highest peak known to mankind, is a fitting comparison for the size of our universe. That's a lot to wrap your head around, isn't it? But here's the kicker. That's not even the whole story. You see, our universe isn't just sitting still like a mountain. No, our universe is always on the move. It's expanding, getting larger and larger every single second. It's like a balloon being filled with air, always growing, always stretching. This expansion started about 14 billion years ago with a big bang. And ever since that moment, our universe has been growing. It's not like a race with a finish line where we know when and where it'll stop. No, this expansion is happening all the time, in all directions, without any end in sight. Now, when we talk about the universe, we're not just talking about stars and planets. We're talking about galaxies, nebulae, black holes, dark matter, and countless other celestial phenomena. Each of these elements is a part of our universe, contributing to its vastness, its complexity, and its beauty. And here's another fun tidbit for you. Even with all the technology and knowledge we have, we still can't see the whole universe. We can only see a small portion of it. That's how incredibly large it is. So the next time you look up at the night sky, remember, you're seeing just a tiny fragment of the cosmos. But isn't it wonderful to know that we're a part of something so grand, so infinite, and so utterly breathtaking? Now, you might be wondering, how old is this mind-bogglingly vast universe? Imagine the universe as an incredibly complex and ancient tree. Just as we can determine a tree's age by counting its rings, scientists have come up with their own methods to estimate the universe's age. Naturally, there's a bit more to it than counting tree rings, but the principle is the same. Our story begins with an event known as the Big Bang. Contrary to what the name might suggest, it wasn't an explosion in the traditional sense. Instead, think of it more as a sudden expansion, a moment when all matter, energy, and space itself began to expand rapidly from an extremely hot, dense state. Over time, as the universe cooled, energy converted into various particles, forming atoms, stars, and eventually, galaxies. This process set the stage for the universe as we know it today. But how can we be sure this is what happened? Well, one of the most compelling pieces of evidence is something called the cosmic microwave background radiation, or CMB for short. This radiation is a faint echo of the Big Bang, still detectable today, almost 13.8 billion years later. The CMB is like the universe's baby picture. It gives us a snapshot of the universe at a very early age, just a few 100,000 years after the Big Bang. By studying the CMB, scientists have been able to estimate the age of the universe with remarkable precision. Of course, this is all a bit of an oversimplification. The actual process involves complex calculations, cutting-edge telescopes, and a deep understanding of physics. But at its core, it's a bit like counting tree rings, only on a cosmic scale. So, when we say the universe is around 13.8 billion years old, we're talking about a time span almost impossible for us to comprehend. It's a testament to the incredible power of scientific inquiry, and a humbling reminder of our place within the grand tapestry of existence. Ever wondered how many stars are out there in the universe? Well, let's take a cosmic journey to explore this fascinating question. Galaxies are sprawling space systems composed of dust, gas, and countless stars. The number of galaxies cannot be definitively known, but Hubble Space Telescope observations suggest a ballpark figure of around 2 trillion galaxies in the observable universe. Now that's a lot of galaxies, ain't it? But wait till we talk about the stars. Each of these galaxies houses a vast number of stars. Our own galaxy, the Milky Way, is a pretty average galaxy, and it alone contains about 100 billion stars. Imagine, if you will, the sheer number of stars in 2 trillion galaxies. To put this into perspective, let's consider a comparison. If we were to count every grain of sand on every beach on Earth, we'd end up with roughly 7.5 quintillion grains. That's a 7 followed by 18 zeros. Yet, the number of stars in the observable universe is estimated to be more than this. Yes, you heard me right. There are more stars in the universe than there are grains of sand on all the beaches on Earth. Every star, like our sun, is a glowing ball of gas that generates heat and light through a process called nuclear fusion. They light up the dark recesses of space, and many have planets orbiting around them. They are the primary sources of light in the universe, and their twinkling presence has inspired countless stories, myths, and legends throughout human history. Isn't it amazing to think about how each star we see in the night sky is just one among an almost incomprehensible number of others? Each one, a distant sun, perhaps hosting planets of its own, and each one playing its part in the grand cosmic ballet of the universe. So each star you see in the night sky is just one of countless others in our vast universe. But what about the mysteries of the universe, like dark matter and dark energy? Now these are two of the most intriguing enigmas in the whole of astrophysics. They're like the invisible puppeteers pulling the cosmic strings, yet we can't see them or interact with them directly. Let's try to unravel these mysteries. Imagine the universe as a giant cosmic soup. The stars, galaxies, planets, and everything else we can see, they're the vegetables floating in our soup. They're tangible, visible, and make up about 5% of the ingredients. But what about the rest? What's the broth in our cosmic soup? That's where dark matter and dark energy come into play. These two mysterious entities make up about 95% of our soup. Yet we can't see them, taste them, or touch them. They're the invisible broth giving substance to our cosmic soup. Now let's talk about dark matter first. This is a type of matter that doesn't interact with light, making it invisible to our eyes and our telescopes. But we know it's there because we can observe its gravitational effects on galaxies. It's like the wind. We can't see it, but we can see the leaves rustling in the trees. And then there's dark energy. This is an even bigger mystery. It's a form of energy that's causing the universe to expand at an accelerating rate. It's like a silent force pushing the vegetables further apart in our cosmic soup. The more soup there is, the faster the vegetables move apart. So why does this matter, you may ask? Well, understanding dark matter and dark energy is key to understanding the universe itself. It's like trying to understand the ocean while only studying the fish and ignoring the water. So while we can't see it, dark matter and dark energy are the unseen forces shaping our universe. They're the silent conductors of the cosmic symphony, the invisible ink writing the story of our universe. And even though they're hidden, they're an integral part of our cosmic narrative. So what's next for our universe? The future of our universe is a topic that has fascinated scientists, astronomers, and cosmologists for centuries. It's like imagining the end of a story, but this story is on a cosmic scale. So let's peer into the cosmic crystal ball and explore some of the theories about the future of our universe. First up, we have the Big Freeze. This theory suggests that as the universe continues to expand, stars will gradually burn out, leading to a universe filled with black holes and dead stars. Over trillions of years, even these black holes will evaporate, leaving a cold, dark universe. It's a chilling thought, isn't it? Then there's the Big Crunch. This is the polar opposite of the Big Freeze. Here, the theory proposes that the universe's expansion will eventually slow down and reverse. This means everything, from galaxies to atoms, will be pulled back together in a cosmic implosion. It's as if the universe is taking a deep breath in, only to exhale everything back into a singularity. Finally, we have the Big Rip. This is perhaps the most dramatic of all. In this scenario, the universe's expansion doesn't just slow down, it accelerates. Eventually, this acceleration becomes so intense that it rips apart galaxies, stars, planets, and even atoms themselves. Imagine being pulled apart at the seams. That's the Big Rip for you. But remember, these are just theories. The truth is, we're not entirely sure how the universe will meet its end. We can only make educated guesses based on our current understanding of the cosmos. Perhaps one day we'll have a clearer picture. While the future of the universe is uncertain, one thing is for sure: our fascination with the cosmos will never end.